Hello and welcome to Unit 1.3, Chemistry of Life, in our class about cells. In this unit we're going to be talking about water, acids, and bases. My name is Lauren Davis, one of the instructors of this class. So almost 75% of the Earth is covered with water. In fact, when you see it from space, you'll see that it's mostly blue because it's mostly covered by water. We are considered a water planet. Well, the same is true for our cells in our body. 75 to 90% of our cells is made up of water. Below you see a water molecule. It's made up of one oxygen and two hydrogens. The hydrogens are kind of attached down at the bottom in those angles, which becomes important later. Water is considered a polar molecule because of its structure. You see that it has a slightly negative charge up on the top of the oxygen atom there, and it has a slightly positive charge at the bottom where the hydrogen atoms are attached. It contains two hydrogen, one oxygen, and the charge is slightly negative at one side and slightly positive at another. I think of it a lot like a magnet. A magnet has a north pole and a south pole. Because of this slightly negative and slightly positive charge, it forms what's called a hydrogen bond with other water molecules. A hydrogen bond is the attraction between the slightly positive and the slightly negative charges on two different water molecules, and they stick together. A lot like putting two magnets together, they will stick together because of the opposite charges. Water molecules are the same. Because water molecules stick to each other, they have this property called cohesion. And that's because the hydrogen and the oxygen stick together. And because they have this cohesive property, they have a relatively high boiling point. Water has some other interesting characteristics. It's one of the only substances that we can find on Earth that exists in all three states of matter. Liquid, of course, is the water. Solid is ice, and we can find ice at the north and the south poles. And it also can be found as a gas, and that's water vapor that we find in the air around us, and it can be seen as clouds. Water has another interesting property in that it expands when it freezes. You know, most things when they get colder contract, but because ice, when it forms, actually expands because of the bonds, it actually becomes less dense when it forms ice. That allows ice to float. If ice contracted like most of the other substances we find, ice would sink when it got colder, and then a lake or a river would actually freeze from the bottom up instead of the top down. When ice formed, it would sink to the bottom. But water doesn't do that. It actually expands and then floats to the top. A solution is a mixture of two or more substances, and it has a uniform composition. I like to think of Kool-Aid as a mixture or a solution. Okay, if you stir it up real good, the sugar and the flavoring and the water all form a uniform color and texture throughout. Because it's uniform throughout, it's considered a solution. In pure water, a tiny fraction of the water molecules naturally separate from each other. So that and below you see two chemical equations. One is water, and it separates into hydrogen ions and hydroxide ions. You can also see the other equation below that. It separates into two different ions as well. An ion is just simply an electrically charged atom. It's just a property of water. So hydroxide is where it's just an oxygen and a hydrogen forming a molecule. It has a slightly negative charge. A hydrogen ion is released when water releases a positively charged hydrogen ion. Hydronium, H3O, forms when another H2O accepts that hydrogen ion, and it has just one more hydrogen ion in that molecule. Acids, bases, and pH. A solution can be acidic, and an acidic solution has a pH of 0 to 7 due to the increased concentration of hydronium in a solution of water. Base has a pH of 7 to 14 due to the decreased concentration of hydronium in the solution of H2O. A neutral is pure water, and it has a pH of 7. pH is called percent hydrogen or potential hydrogen, and it's a scale to measure the acidic or basic nature of solutions. So acids and bases are important to living systems. On the diagram to the right, you can see many solutions that are common in our daily lives, and you can see what the pH is. You see battery acid is way down at 0. That's highly acidic, and it can burn you if you touch it, and then as you get closer to 7 or neutral, you get less acidic solutions. Then when you hit 7, that's neutral or distilled water, and then as you continue to go up, you get basic solutions. And when you get up to the most basic solution that we have on this chart is household lye, or NaOH, sodium hydroxide, and that solution is very caustic, meaning that it can burn you as well. So at both ends of this scale, down there at 0 and up around 14, those are both very hazardous solutions. So in our body, we need acids and bases to be the right acidic nature in order for enzymes to function and in order for food to digest correctly. It influences the respiration within our cells, and there are many biochemical reactions that are dependent on the pH of the solution in our cells and in our bodies.